Kia ora and welcome to video number 2 of Organic Chemistry. Today we're going to be looking at reaction types, so things that you should remember from last year to do with reactions and reaction schemes. Now, I'm a visual person. I like pictures and I like things like that. So it is my recommendation to you that you make yourself a huge reaction scheme. The bigger the better, pretty much. I've recommended this for the past couple of years, and I've even seen some very interesting photos of laminated reaction schemes that have been put on the back of shower glasses. So you're standing in the shower and you look through the glass and you can see your reaction scheme. That's probably as far as I would take it. But there's no harm in making a big reaction scheme and sticking it on a wall somewhere where you can look at it all the time. I used to have multiple reaction schemes above my desk when I used to study. I was both at school and at university. So, here we go. Reaction types. These are ones you should be able to remember from last year. So you've got addition reactions. Addition reactions, so alkenes react if you add hydrogen across the double bond, chlorine across the double bond, bromine across the double bond, water across the double bond, and hydrogen halide, so that's HCl, HBr, HF, all that kind of stuff. And you have to remember about Markovnikov here. So Markovnikov's rule, remember the rich get richer, but you can only say that as your way of remembering which way around it goes. So the carbon with the most hydrogens will get the hydrogen. The carbon with the least hydrogens will not get the hydrogen. So you have major and minor products. If you're going to complain to me about how I spelt Markovnikov, go ahead. They don't actually quite know how to spell his name 110% in English. There's about 4 different ways of spelling it. You know, W is pronounced as V and V is pronounced as F. So yeah. Go ahead and spell it however you want to. Addition polymerization, so that's the addition reaction you did, the polymer stuff you did last year, where you all started with alkenes or maybe even an alkyne. Okay, so addition reactions. Substitution reactions. Substitutions where you are substituting one hydrogen for something else, or alcohol groups. So you've got alkanes with halogens, so that is limited to mono substitution, so you'll have carbons in a chain and one hydrogen will be substituted with the halogen. So instead of a hydrogen you'll have a chlorine, or a hydrogen you'll have a bromine. You probably would have done a reaction with that to do with bromine water and alkenes versus alkanes. Right, so the alcohol substitution of alcohols with hydrogen halides, so that's PCl3, PCl5, SOCl2. These three do the same thing. They will add chlorine. So this is phosphorus trichloride, phosphorus pentachloride, and thiochloride. I can't even remember that one. It'll come to me. And then haloalkanes with ammonia and aqueous potassium hydroxide. So haloalkanes with ammonia and a basic solution will create an amine. So haloalkanes to amines. Alright, so here we've got alkenes to haloalkanes, alkenes to haloalkanes, alkenes to alkanes, alkenes to polymers. Here we have alkanes to haloalkanes, alcohols to haloalkanes, haloalkanes to amines. Okay. Oxidation reactions. Now, of course, we do look at redox again this year. That is one of our internals. But redox isn't just, a separate topic. We look at oxidation in organic chemistry. In fact, we look at it in some other stuff as well. But in organic chemistry, we look at the oxidation of primary alcohols to form carboxylic acids. This is what you did last year. I'm going to show you something interesting about that this year, about that reaction. So you looked at, these are what we call strong oxidants. Yep, they will take your primary alcohol straight through to carboxylic acid. Alkenes with permanganate. You probably did these reactions in class. I'm hoping you did them in class. Right, so they will, elimination reactions, water from alcohol. So if you eliminate water from alcohols, then you will make an alkene. So you're going backwards. Eliminate hydrogen halides from haloalkenes. Again, you'll make an alkene. And acid-base reactions of carboxylic acids and amines. This one is brilliant because you remember I might have told you in class, amines smell fishy. In fact, the reason why fish smell fishy is because of amines. You add lemon juice, which is a carboxylic acid, is acetic acid, to that, and it will react in an acid-base reaction to make the salt and water, and that's why your fish doesn't smell fishy anymore. Brilliant. Alright, I'm going to finish this video here because we're going to go into isomers next. So that's it. There are many examples, and I do have some really cool questions to do in your workbook around these reactions. So when you get your workbooks, I will tell you which pages to do. Awesome, I'll see you next time for isomers.